Hello, and in this video we're going to be walking you through interpreting the MANOVA output. So just to remind ourselves again why we did the MANOVA, it was to look at the impact of gender, which had two levels in this instance, males and female undergraduates, and whether people identified as high or low on non-materialistic goal attainment. And whether that had any impact on subjective well-being overall, and then if it does, we'd want to break it down and understand what facet of subjective well-being it was involved. So this is the output that we generated for the between groups MANOVA. So it's a two-way between groups MANOVA. So the first box we'll just double check is that we've actually got everything set up in the way that we thought. So for the gender variable or sex variable, we've got males and females, the two levels. We've got 90 males and 88 females. In the non-materialistic aspirations median split variable, we've got low and high materialistic attainment group with 93 and 85 in there respectively. When we break it down, we've got less equal groups when we consider both independent variables together. So we have 58, I think, is the largest subgroup size, and 32 is the smallest subgroup size. Luckily, when we checked the data assumptions, we haven't violated things like the boxes test, which would cause a problem for interpretation. If we did violate that assumption and we've got these unequal groups, it would be problematic to interpret the MANOVA potentially. But we didn't violate those assumptions, so that's a good sign. So the first thing we might start to look at is the way that overall on cognitive well-being, we can see that there's a score of 3.1, for social well-being 3.3, and for emotional well-being 1.1. So they're measured using different variables, so it's hard to compare directly between them because obviously they've got different scales of measurement. But we can see some of the patterns within this. If we look at males and females within that, males are scoring higher, lower on cognitive well-being than females are overall. And then if we look at overall, regardless of gender, we see that people in the low non-materialistic attainment group are scoring lower on cognitive well-being than the higher materialistic attainment group. And so we go through and look at each of these to get a sense of the patterns that are going on in the data. And what I would tend to do is if I was doing this research and reporting this, I'd start to make notes to myself as to the broad patterns I'm seeing overall, between males and females overall, and between the high and low materialistic non-materialistic attainment groups overall, those sorts of things, just to get a feel for what's going on. But the next thing that we're going to be interested in looking at are our multivariate tests. Now, this is interesting because what it does is it will give us the main effects for each of our independent variables. So our first independent variable is gender or sex, and our second independent variable is non-materialistic attainment group, and then the interaction between the two. But it looks at these main effects when we've considered all of our three dependent variables together, and conceptually that kind of is subjective well-being overall. So what we can see is because we've got unequal groups and we have some problems with normality, I would interpret the p-Lies trace. If we had equal groups and no issues with normality, I'd interpret the Wilks lambda. And for the most part, I'll ignore the other two. There's only very specific occasions when you might want to use one of those. So for the p-Lies trace, what I'll be looking at is things like my statistical significance. So we can see that that value is less than 0.05. So that suggests that between males and females, there's a difference when we look at these three dependent variables in a multivariate way. All at once, on subjective well-being overall, there is a difference between males and females. So our next variable we'd look at is the non-materialistic attainment group. We can see that that's that's essentially, if we rounded that up, it would be right on the borderline of statistical significance. Some people would actually say that that isn't statistically significant. Some people would try and argue that it is, because it's not, when you round it up, it's not greater than 0.05. So you'll see people talking about that in all sorts of different ways. I would probably describe it as a borderline statistically significant result, but that should be treated with caution. I think it depends on, as long as you're clear about what that p-value actually is, then and your interpretation of it, then the reader will judge as well. But and then we'll look at the interaction, and actually again this is right on the money kind of thing. So we some people would look at these with great suspicion, but we'd report all of the results and see what's going on. I think it does warrant looking at the individual dependent variables separately, but that would be a decision that you'd have to defend, whichever approach you take. In terms of then, we'd also want to look at the measure of effect size. And you can see that we start off with a very large effect, and then there's also a large effect, and there's still a fairly large effect when we get down to our interaction effects. Sorry, the intercept is the very large effect. But we've still got a large effect if we think about our cutoffs. So if we go back to the slides from the MANOVA lecture, we could look at partial eta squared, which is the thing that we have produced, and we can see that, yeah, we've got a very large effect for all of them. So it's worth kind of exploring further. So that's what we'll do now. We'll look at, this is the multivariate main and interaction effect here. Now we want to break it down and look at the individual dependent variables. And so we look at the tessor between subjects effects box. You can ignore these first two rows for the most part. What we are interested in are the sex, non-materialistic attainment category groups, and the interaction between the two. But this time you can see it's been split down by each of the dependent variables. So we've got a separate statistical result for each of these. And so I think the first thing that you'll notice when you come across is that actually even if we use a 0.05 cutoff, none of those are statistically significant. Borderline, but non-significant. And actually there's an argument that when you get to the interpreting what we call the univariate tests, that you should be applying a Bonferroni correction, or some kind of correction to account for an increased type 1 error risk, because we're doing multiple significance tests. There's quite a bit of debate about this, so there's actually a folder on the Blackboard page about the Bonferroni correction and the criticisms of it, and so again you'd have to pick an approach and justify if you apply that the Bonferroni correction, or if you apply a modified version of that like the whole Bonferroni correction, or you don't apply it for a very specific reason. You have to justify it and be prepared for there will be some level of disagreement with whichever option you choose. But I think the convention is to apply some form of correction. As a compromise, applying something like a whole Bonferroni correction might be a good approach. But we'll take the really traditional uber-conservative approach, which is that we would divide our initial cutoff for statistical significance, which is 0.05. We would divide that by the number of comparisons within this test here, which is 3, and we'd get a new p-value, which I think is 0.017. And we'll only class something as statistically significant if it falls below, or is it 0.017 or below. So actually for gender, even though we found a main effect, multivariate main effect, when we considered these things all together as sort of subjective well-being overall, there is difference. If we break it down, we can't find that anymore. We can't see where exactly it's happening. So it could be that we're making the argument that it's only when we think about these things in combination. It could potentially be that we lack the power to identify differences between the genders, and that's why we don't reach statistical significance in any of these. We can see that the larger effect is associated with emotional well-being. So that might be where the main kind of contribution to that multivariate effect is coming from. So mainly perhaps emotional well-being and cognitive well-being, but they're not statistically significant on their own. So we'd apply this approach as well to the non-materialistic attainment groups. Because it was sort of borderline, we could make the argument that we want to investigate it further. And we find actually the only thing that we see a difference on is this social well-being, and that is smaller than 0.017. And we can see that that's a pretty large sized effect. That is a... Sorry, that's a pretty small-sized effect is what I'm actually meant to say. It's sort of, if you look back at that table in the MANOVA slides, a medium-sized effect with partial eta squared, I think, is 0.06. So that's a fairly small-sized effect. And then when we look at the interaction between the two, again, none of these actually falls below 0.017. Now, the Bonferroni correction is particularly conservative, so it puts a huge dent in the power of analysis, which is concerning, and that's a reason for applying a sequential Bonferroni instead, or something like that, which is less conservative. And again, we can see that these are small-sized effects, though, but these don't meet the new Bonferroni correction cutoff of 0.017. So we've got some interesting results. The majority of that, the lack of clear univariate statistical significance is probably a payoff between our things like our Bonferroni correction, or power, or it may be that we only see it when we look at these things in combination, when we consider them as kind of a lump of well-being as opposed to the individual variables. But it would still be interesting to then report the descriptive statistics for each of these. You'd still need to, so you get an idea of the trend. It's useful if we look at, say, differences between males and females overall. So we can see, using our estimated marginal means, that there is for cognitive well-being, females tend to score higher on average. Social well-being, again, females look like they're scoring higher, and for emotional well-being, though, males are looking like they score higher. But they're very close. And then if we look at the estimated marginal means for the non-materialistic and high and low groups, so ignoring gender, we see that again in each instance the higher non-materialistic attainment group is going in the direction we expected, but it's being wary of drawing too many conclusions, because obviously for some of these variables there wasn't a statistically significant result. And then finally we have the split down by both of our independent variables. So we can see that males in the low non-attainment materialistic group are scoring higher than interestingly than males in the high non-materialistic attainment group, and so on. But again, you have to be careful because none of these reach statistical significance, but you would report the patterns of results in a big table. To understand the interaction effect, we could explore these. It's based on each of our we've split it up in different ways. So we've got, for our cognitive well-being in this example, we've plotted the lines as the materialistic group that people are belonging to, and gender or sex along the x-axis, and then we've got the kind of the opposite of that in this graph. So if you were going to report a plot, you'd only report one of those, whichever one you thought actually helps to explain the results more clearly. So I think the interaction effect here looks like it's between the on the emotional well-being variable. We've got a crossover in the lines, so there is potentially something going on for the low non-materialistic attainment group, and so on. And again, an interaction here. This is the alternative way of presenting that data. So you'd keep it consistent. So if you choose for males and females to be along the x-axis in one graph, you keep that consistent, the layout across all of them. So we've got quite a complex sort of set of findings that you'd have to then unpick as to whether that actually provides support for our hypotheses. So that would make for an interesting discussion section. But hopefully that's given you an idea of, when you've got real-world data with a MANOVA, some of the challenges to interpreting that.